G'day guys, got this older model 4500 come in, and I was looking at it and I saw something. I said, oh, that looks pretty rough, a hot melt glue there. And then I had a better look and have a look at this. This is quite funny. Well, it's functional, but that mess there, you see where that vertical MOSFET is, the one with the little tab and the hole through the middle on the heatsink part of it, on the metal part, and you can see down there it's got 3 legs that are soldered to the board. Well, that device there, and I'll get a pointy implement for a sec. I'm going to do this left-handed because I'm holding this with the right. Okay, see that thing there? That. Well, that is one of these is meant to be here. So someone didn't bother getting the whatever what is that, FDS something or other, I can't remember the number, but they didn't get the right component, and they stuck a normal MOSFET there and just hot melt glued it to the big capacitor. I think that's rather, well, you know, something that's not to be expected. Now this is an older 4500, and the way you can tell, there's only one row of inductors and capacitors right there. There'd be another set on the later ones, which are the same as the 5000, but I think they ended up just using the overall 5000 design board for the later model 45s as well. Don't quote me on that, but I'm pretty sure something like that happened, in my opinion. Right, but the other thing to watch out on these boards, and I'll just zoom back out, is you know, this has got the pins, so you know it's an old one. It's got those push-on pins rather than the Mylar setup. And the other one too, you're going to notice this on a lot of these. I've mentioned this before. I'll just go left-handed on the camera and right-handed on the point, because otherwise it's too difficult. Okay, let me see where I am. It's very difficult to see, but we'll start where very easy to see, well, for me anyway. You can see there's a different texture in the paint right along this line here compared to anywhere else on the board. And if you have a good look where this new paint is, or it's been over painted, there's a lot of these went out with these capacitors with the wrong value. So I think they're meant to be 18 nanofarad. I don't know what went in there. I never bothered measuring it. But I think I've mentioned this before, but this is when it's just straight out the box. It looks like it's definitely a factory job. It is too neat to be done anywhere else, I'd say. But there's another few capacitors that need to be checked, and yeah, there's one there that's been replaced. So I can see that change of colour around here. It's more of a milky white. There's that one there, and I'm pretty sure there's another couple somewhere. I'm just looking, see if I can spot them, but yeah, just looking for the change of colour in the paint. Actually, it's very interesting because there is actually a colour change in the paint on this near that damping MOSFET right there. I don't know why, but I can see there's a colour change there. Very yellow here. Maybe that's because of heat from the ADG 333 getting hot. But yeah. Oh, there's another couple, I think, here and here. it's been machine done. It's been redone by machine. It's really hard to tell. Let's have me a good look at this. But yeah, it seems like that's the only real changes. So the old model just doesn't have that extra lot there. But yeah, that I don't know longevity of that part sitting there like that. I think I'll have to change that. I've got some genuine ones. I think the actual genuine part they put out of production. The oh, if I can remember the number of it, what was it? FTS 2672, FTS 2670. It's one of those, something like that anyway. That's what they were. And the reason why they use those is because you can heat sink them to the board. You can see that on the board here. If I get under there, you see those little holes there. That's all through plating, and underneath where the chips go, they've got all that through plating, but it's all flooded with solder, and the solder also gets onto the IC bottom. It's a heat tab there as well. So for any instantaneous thermal build-up, it'll just dissipate it at a good rate of knots, and I suppose that makes the output stage last longer. But I don't think it's a good idea sticking that. I don't know. I mean, it works. You know, some people drive larders. They work. But, you know, I wouldn't drive one. And I don't think I would like that in my detector either. So I think that might be one I'm going to flick out. The other thing too on this one, I've noticed that the inductor here on the transmit line, this one, if you can see, it's leaning over this way. There, it's been hot melt glued, but it's been hot melt glued leaning over. And if you look in the box on these things, it has another piece of metal protrusion that lines up right here, goes along that line. So that may be hard up on that. Being a toroidal core, I don't think it should interfere too much, but I wouldn't want you know, any touching of the metal there. So I might heat that up and just push it back over. It's only hot melt glue, it's easy to do. So that's a 4500 older one, and this has come in for full upgrades. And as we say, the sign's still up there. Oh, there you go. So I'll get stuck into this, and yeah, we'll get him done. And we're going out to the test site very shortly, and we're going to be doing a lot of testing. We've got a lot of detectors we're going to test, different things done to them, and we're going to see which one's the best. I'll make a video of it anyway, so you'll be able to see that later. Anyway, catch us.